Hello everyone. Today we will discuss AWS CloudWatch and how it enables monitoring and observability across your entire cloud infrastructure. In this lecture, we will cover CloudWatch capabilities, CloudWatch logs, metrics and alarms, logs insights, and how to design a production observability setup. CloudWatch, monitoring and observability. CloudWatch is the central observability platform for AWS. It collects logs, metrics, and events from virtually every AWS service automatically. Services like Lambda, ECS, API Gateway, and RDS send telemetry data to CloudWatch without requiring any agent installation. This makes monitoring seamless because there is no need to install or manage additional agents. CloudWatch turns raw telemetry into actionable signals. Alarms are triggered when metrics breach defined thresholds. Dashboards provide real-time visibility into system health, and Logs Insights allows you to query large volumes of log data quickly. CloudWatch provides key capabilities, including log storage and search, metrics as time series data, alarms and notifications, and dashboard visualization. It also supports Logs Insights queries for deep analysis. For modern AI systems, CloudWatch plays a critical role in tracking inference latency, token usage, error rates, and pipeline throughput, enabling better performance monitoring and cost control. CloudWatch logs. CloudWatch logs organizes log data into a clear structure. A log group acts as a container for logs from a single service. A log stream represents a sequence of log events from one source, such as a Lambda execution or ECS task. Each log event is a time-stamped message. One of the most important practices is setting a retention policy. By default, logs never expire, which can lead to increasing storage costs. You should always define retention periods based on the type of logs, such as 30 days for debugging, 90 days for application logs, and up to 1 year for audit logs. Structured logging is highly recommended. Logs should be written in JSON format instead of plain text. This allows CloudWatch Logs Insights to automatically parse fields, making queries faster and more efficient. Metric filters can extract numeric values from log data and convert them into metrics. Subscription filters enable real-time streaming of logs to other services like Lambda. Logs can also be exported to S3 for long-term storage and archival. Metrics and alarms. CloudWatch metrics are automatically collected from AWS services. For example, Lambda publishes metrics such as invocations, errors, duration, and throttles without any configuration. In addition to default metrics, you can create custom metrics using the Put Metric Data API. These allow you to track application-specific values, such as token usage, queue depth, or business KPIs. Alarms monitor these metrics over a defined time period. They transition between 3 states: OK, alarm, and insufficient data. When an alarm is triggered, it can perform actions such as sending notifications via SNS, invoking a Lambda function, or adjusting auto-scaling capacity. Composite alarms allow you to combine multiple conditions using logical rules. This helps reduce alert fatigue by ensuring alerts are only triggered when multiple thresholds are breached. It is important to define alarms for critical signals. For example, monitor Lambda errors, execution duration, and throttling. For RDS, track CPU usage, database connections, and available storage. CloudWatch Logs Insights. CloudWatch Logs Insights is a powerful tool for querying log data using a SQL-like syntax. It allows you to analyze logs interactively and extract meaningful insights quickly. Logs Insights can query one or multiple log groups at the same time, making it easy to correlate events across different services. Structured JSON logs are automatically parsed, which means fields are immediately available for querying without additional processing. The query language includes commands such as fields to select data, filter to narrow results, stats to aggregate values, sort to order results, and limit to control output size. You can use Logs Insights for common use cases such as finding errors in the last hour, calculating P99 latency, tracking token usage per tenant, or tracing a request by its ID. Queries can be saved for reuse and even pinned to CloudWatch dashboards for continuous monitoring and visibility. Production Observability Setup. A production-ready observability setup starts with structured JSON logging across all services. Every Lambda function and ECS task should generate consistent and structured logs. Retention policies should be set at the time of log group creation to prevent uncontrolled storage growth. This ensures cost efficiency and proper log lifecycle management. Alarms should be configured for all critical system metrics. This includes Lambda errors and throttles, API Gateway 5xx error rates, RDS CPU usage and connection limits, and SQS depth. For AI systems, it is essential to create custom metrics for token usage and set alarms on cost thresholds to prevent unexpected overspending. Dashboards should be created for both detailed service-level monitoring and high-level system overviews. This allows teams to quickly understand system health and identify issues. All alerts should be routed through SNS and integrated with communication tools like Slack using AWS Chatbot. This ensures that teams receive real-time notifications and can respond quickly to incidents. Conclusion: CloudWatch provides a complete monitoring and observability solution for AWS environments. It automatically collects data, enables powerful analysis through logs and metrics, and supports automated responses through alarms. By implementing structured logging, defining meaningful metrics, setting up effective alarms, and building clear dashboards, you can create a robust observability system. This approach ensures better system reliability, improved performance, and greater control over operational costs in production environments. Thank you for watching.